path, that is AI powered medical image analysis. Now बेसिकली ये जो प्रोजेक्ट का मेरा नाम है वो है बायोमेडिकल इमेज डिटेक्शन एंड फीचर एक्सट्रैक्शन यूजिंग मशीन लर्निंग एंड डीप लर्निंग. नाउ इन दिस डीप लर्निंग you can even tell that it's not deep learning, it's deep neural network, but both are same. Okay, now basically here I have not used machine learning that much, but yes, whatever I have used that deals only with the deep neural networks. So here I have used a RaceNet 50 v2, that is RaceNet 50 version 2. Now why this 50 in RaceNet tells? What this 50 in this RaceNet tells? This 50 in RaceNet tells us that there are 50 layers, and this RaceNet is nothing but already a pre-trained model. Okay? It's already a pre-trained model on CNN. So basically, you know CNN. What is CNN? It's a convolutional neural network that helps in image classification and boundary detection, feature extractions from images. Okay. Okay. So basically, on this we have various type of pre-trained model like VCGG. Now, one of the other is RaceNet 50 and RaceNet 50 V2. Now, what I have done in this code is that first of all, let me tell you, let me show you the UI. We have breast cancer detection, skin cancer detection, blood detection, lung detection, chest X-ray that will tell you whether you are suffering from a pneumonia or not, and an ECG detection. So let me show you an example of skin detection. Like I have chosen this model, and then here from I already got an image from ChatGPT just for the testing purpose. Even I have the test data as well, but just to be unbiased, I have taken the image from ChatGPT to tell you. Now see, I have also made an universal detector. Now universal detector, what does this do? So this basically consists of all, means here actually in the backend what is happening is that in the universal detector we have already a code, and that code or that model has been trained on all these four data set. It does not deal with the ECG and chest, but yes, it deals with the breast, skin, blood and lungs. So basically is this universal detector will detect all those four types. We don't have to choose the model separately and then upload the file. Instead we can directly upload to this universal detector, and it will detect and tell me which is the cancer or not. But yes, this is trained on a very small data set, nearly about 500 per model, so this is not that much of accurate. But I will, yes, I'm also dealing with this, but right now these are the things. Now like see what the images that I have given is malignant, that means it is suspicious and cancerous. Now I have also used a Grok AI, that where it will give some suggestion, like if I ask for medicine, suggest some medicine, though it's not a doctor, so it will not suggest the medicine, but yes, it will tell like potential skin malignancy, there are various medicines like this that might be considered depending upon the specific condition. Okay, now this is AI, this won't tell you the exact medicine, okay, that you need this, that, because you need to consult it to the doctor. Now this is basically a project that I have been working over. Okay, and this was something like my dream project that I want to do in the field of medical. Now I know that detecting cancer is not an easy task. Just by making this or training the model over 10,000 to 12,000 images data, that doesn't make my model much accurate. Okay, there are various standards that needs to be maintained, data set. Even whatever the data I have used, I have taken it from the Kaggle. Now that, and in the Kaggle, whatever data set I have downloaded, I have whatever the images I have used, that are nearly about 10,000 to 12,000 on an average per data set. So this is not going to make my model much more accurate. Okay, so but still I have tried to do. Now I have another option, like I can make my own data set. For that I have to go to the hospital, I need to take those data set, pre-process it, clean it, extract the features from that, and then doing all these things, data in some sort of data engineering, then I need to make my own data set. Now this is very much time consuming and hectic. So that's why. But yes, my mindset was to make a cancer prediction data set. Now on the YouTube we will say that someone has made the oral cancer detection, someone has made the tumor brain tumor detection, but they have not worked over many cancer detection. But they have either they have deal with the single cancer detection, or some single tumor detection, or someone deal with the only pneumonia detection. So they have individually worked over that project, but I have done, what I did is that I have trained 7 to 8 models, and then I have combined all together. Okay, here you could see that in the backend we have services. Even we have the models routes, as you could see the in this model underscore loader dot py. Actually what is happening, whatever the models are being getting trained are getting models which are getting trained are saved, and these models are being loaded here, and then routes we have, and then services. Now and what is happening actually is that whenever in the services, like they'll give you, let me show you an example, like bridge services. What is actually happening is that we are here we have put an code to predict the image. Now as soon as the image will be passed here, then the mod from the model loader.py a model will be loaded, bridged model will be loaded, and then it will be whatever it will predict, it will be taken and then passed to the front end. Now basically this routes, you as you can see that here is the route python code there. From there it's handling all the routing of services and model.py. Okay, now here also we have the training train all pi. Okay, so we have all this type of models kept all together. Now why we have used the docker file? Now let me tell you what actually happened is that first of all uh, I have deployed the backend on Hugging Face. Now you must be thinking that why I have uploaded why did I uploaded it on Hugging Face? Now as you could see that this is the BioVision backend. This is actual my backend that is working on. Okay. So as you could see there, okay. So this actually my lung model is getting a bit unavailable. I don't know. Sometime it's working, sometime it's not working. But yeah, lung model is working, sometime it's not working, that I will check. Now as you could see that what is happening is that why I use this why but yes, my long lung model is working. Sometime I don't know, some problem in routing that I will later on fix it, but yeah, it's working, sometime not, that's something different, but yes, basically it's working. Now you must be thinking that why I have used like why I used Hugging Face model, why not render? Okay, so basically you can upload it on the render as well, no problem. But actually what happened is that in the random render, free deployment provides only 512 MB. Okay, now you only have two options: either buy the subscription. Now for subscription you have $7 subscription that gives you the same storage 512 MB, and second one is $25 that gives you near about 2 GB RAM. Now just think, like when I have, first of all I have uploaded on render. Now what happened is that after uploading on render, my backend got deployed over there, even my front end also got deployed over there, and I have allowed the cross origins, made the allowed the origins, and have connected backend plus front end both together. Now actually what problem I face is that whenever my front end is passing anything to or any query to the backend, what backend is running, it's showing the backend is running, but it shows some problem, like it is not able to give the result. So when I have gone through the logs, and as I gone through the logs detail, then I got to know that my backend is running, but it is running out of memory because it's only 512. Now you must be thinking that so what, 512 MB is enough. But when you will go through this requirement.txt file, then here you could see that it's downloading flags goes unicorn, python.net, tensorflow, keras, scikit-learn, joblib, pillow, OpenCV, numpy, pandas, scipy, and then torch geometric network, httpx request, hugging face. So all these things are being downloaded, and these things are being downloaded while deploying the backend. Now where will so much of storage will come from in the local host. You have the storage on your local drive, that's why you are able to run on the local machine. But at the time of deployment on the server, you are getting only 512 MB. How will you get so that's why now I got, that's why I have used Hugging Face model. So Hugging Face model, first of all, I have deployed there. I have made a data set, and there I have what to say, committed all my committed or uploaded all my train model, and then after that, using Hugging Face, I have deployed there all my models. Okay. And then on and for front end, I have already deployed on the render, so that's not a big problem. And then I have connected it together and still working. As you can see, blood, lungs, everything is working. So some okay, now in the future scope, I'm thinking that to make something more, I'm working to bring more accuracy, though it's accurate, to performing well on training and testing data, as well as the few unseen data as well. But yes, this is the medical line thing, and we need to manage all these things accurately. Okay, so thank you. So if you need the code, just comment. I will give the code to you.